In the first fraction of a second after the Big Bang, the universe was fighting a war, and it almost lost. Every single particle of matter that has ever existed, every star, every galaxy, every atom inside your body, was pitted against an equal and opposite enemy, antimatter. And the rules of physics said they should have been perfectly matched. A flawless, catastrophic tie, which means everything. The Milky Way, Earth, you, should have been obliterated in a blinding flash of pure energy before a single second had passed. The fact that you are watching this video right now is, by the laws of physics as we understand them, completely impossible. So what went wrong? Or more accurately, what went miraculously, bewilderingly right? To understand how close we came to non-existence, you need to understand what antimatter actually is. It's not science fiction. It's not a theoretical concept physicists invented to fill gaps in equations. Antimatter is real. We make it. Right now, at facilities like CERN in Switzerland, scientists manufacture antimatter particles every single day. Antimatter is essentially a mirror image of normal matter, identical in mass, but with every quantum property flipped. An electron has a negative charge. Its antimatter twin, the positron, has a positive charge. A proton is positive, an antiproton is negative. They're perfect opposites. And when matter and antimatter meet, and I mean the instant they touch, they don't just collide. They completely, utterly annihilate each other, converting 100% of their mass into pure energy. Einstein's E equals mc squared working at absolute maximum efficiency. Now here's where it gets terrifying. The Big Bang didn't create just matter. It created matter and antimatter in essentially equal amounts. For every particle born in those first searing moments, an antiparticle was born alongside it. This is what physics demands. This is what every equation predicts. The universe was born with a loaded gun pointed at itself. And within microseconds, the annihilation began. Matter crashed into antimatter across the entire infant cosmos, releasing energy so violent, so total, that physicists call it the annihilation era. In less than 1 second, almost everything was destroyed. Vast oceans of particles, gone. Wiped from existence in the most complete destruction imaginable. The universe was eating itself alive, and it should have finished the job. So why are we here? The answer is a number. 1. For every 1 billion antimatter particles created in the Big Bang, there were 1 billion and 1 particles of matter. That's it. That's the entire margin. A ratio of 1 in 1 billion. A difference so absurdly small that if you were counting atoms in the universe and made a rounding error, you'd miss it entirely. When the great annihilation ended, when every antimatter particle had found its matter partner and both had been destroyed, that tiny surplus of matter was all that remained. All the stars you've ever seen. All the galaxies in every photograph from the Hubble Space Telescope. The 100 billion stars in the Milky Way alone. All of it came from that razor-thin imbalance of 1 extra particle per billion. We are the leftover rounding error of the universe. But here's what keeps physicists awake at night. We have no idea why that imbalance existed. The Standard Model, the most successful scientific theory ever created, the rulebook that governs every particle and force we know, says matter and antimatter should have been created in perfectly equal amounts. The math is precise. The symmetry is absolute. And yet, somehow, reality disagreed. The universe cheated. It broke its own rules at birth. This violation of symmetry has a name, CP violation. CP stands for charge parity, essentially the combined property of having opposite charge and mirrored spatial orientation. In a perfectly symmetric universe, flipping these properties shouldn't change how particles behave. But they do. Slightly. Mysteriously. And nobody fully understands why. It's one of the greatest unsolved problems in all of physics. The first clue came in 1964. Physicists James Cronin and Val Fitch were studying particles called kaons, unstable composites of quarks, when they noticed something extraordinary. Kaons and their antimatter counterparts didn't decay at exactly the same rate. They weren't perfectly symmetric. It was a tiny difference, barely measurable, but it was real, it was reproducible, and it earned Cronin and Fitch the Nobel Prize in Physics in 1980. For the first time, humanity had experimental proof that the universe has a preference, that nature itself is slightly biased toward matter over antimatter. We had found the fingerprint of the miracle that made our existence possible. But there was a problem. The CP violation in kaons was far too small to explain the 1 in a billion asymmetry that created the entire visible universe. There had to be more. And that's exactly what CERN is hunting for right now. The Large Hadron Collider, a 27-kilometer ring of superconducting magnets buried 100 meters beneath the French-Swiss border, accelerates particles to 99.9999991% the speed of light, and smashes them together with energies that briefly recreate conditions from the first trillionths of a second after the Big Bang. The LHCb experiment specifically is designed to study a particle called the B meson, which shows much larger CP violation than kaons. In 2019, LHCb detected CP violation in a particle called the D meson for the first time in history. Every result narrows the search. Every collision brings us closer to answering the deepest question in cosmology. Why does anything exist at all? The answer is written in the debris of these collisions, and we are slowly learning to read it. But here's the mind-bending twist that nobody talks about. Some physicists believe the missing antimatter didn't just vanish. They believe it's still out there, separated from our universe during the chaos of the Big Bang, possibly forming entire antimatter galaxies in regions of space so distant we've never observed them. If this sounds wild, consider that in 2021, the Alpha Magnetic Spectrometer aboard the International Space Station detected 8 particles that could be anti-helium nuclei, the signature of antimatter stars. 8 particles. But 8 is not 0. And if there are antimatter stars, there may be antimatter planets, antimatter galaxies, a shadow cosmos of mirror-image matter, drifting through the void, forever unable to touch our universe without annihilating in a catastrophe that would make every nuclear weapon ever built look like a birthday candle. Here's what this all means for you, and I mean personally, directly, in the most literal sense possible. You are made of matter that won a war 1 billion times over. The calcium in your bones, the iron in your blood, the carbon woven through every cell of your body. Each of those atoms is a survivor, a fragment of the impossible surplus that defied the laws of physics at the dawn of time. You exist because the universe cheated by 1 part per billion at its very birth. If that asymmetry had been slightly smaller, if the balance had been even fractionally closer to perfect, the annihilation would have been total. No atoms, no chemistry, no stars, no time for anything to evolve, to think, to wonder. Existence itself was a coin flip, and the coin landed on heads. And we still don't know why. The universe almost didn't exist. You almost never happened. And the reason you did, that 1 in a billion miracle written into the laws of physics, is still one of the greatest unsolved mysteries in science. At this exact moment, detectors deep underground are counting particles. Accelerators are smashing protons at relativistic speeds. Mathematicians are hunting for the equation that breaks the symmetry. And somewhere in all of that data, the answer to why anything exists at all might already be waiting to be found. The universe has been keeping this secret for 13.8 billion years. We are the first species in the history of this planet to even know the question exists, and we are getting terrifyingly close to the answer. If this made your brain feel small and incredible at the same time, you're in the right place. Subscribe for more mind-blowing facts every week.